you can be pretty fine with threads. I mean, async IO works fine as well. But the thing about async IO, which I'm sure everyone knows, is that if you change the front of the program to be async IO and the back, typically you've got to change everything all in between to be fully async IO, which is also fine if you want to do that. And I think some apps will have to do that. But I think a lot of apps are going to probably not want to have to do that for their entire program. So I think to the extent that you can get away with threads, that's the easiest way to go. So we just have, me and Hervé have just been trying to brainstorm a little bit how we can maybe get a top level view of who's going to do what's the plan for each project, what's Neutron's general plan, what's Nova's general plan, how's this going to look? And then finally, how does that lead into what Oslo might need to be doing? Oslo messaging, Oslo service, who's doing those changes and what do they look like? How would we best organize things to work for both the threading model as well as using async IO purely. And you folks may or may not know that with Oslo DB, which I maintain, we already have an async IO engine facade that I'm not sure if it merged, but it's ready to merge if it's not merged already. So we're just kind of trying to get our ducks in a row for that. That's kind of where me and Hervé are at. Does that answer the question, Hervé?
No.
I don't know if my camera's working or not.
I think the coming section, background task needs, etc., also inherit from the same approach, same question, identifying what are our alternative. Like, just Mike said, I think IO, thread, Eventlet, etc., etc. We also have some library and tools, concurrent future. Like said Mike, we are currently working on a refactor of Oslo service to move away from Eventlet inside Oslo service and maybe replace some feature from Oslo service by Koiteliden and Futurist, who are a good replacement good candidate for a replacement for Eventlet in the Oslo service context. We will probably drop the support of the Whiskey server of the Whiskey feature into Oslo service, and we will delegate this kind of things to services and user. So this leads us to the next section, which is network and HTTP needs. During the previous session, we have discussion about USG, ASGI, etc., etc. I made a teeny proposal about Uvicorn and ASGI ref, but some people already expressed some concern about it. I don't know if you have question.
Yeah, I wanted to ask a question about the Oslo service direction. So do I understand correctly that if Oslo service will be reimplemented by that third-party library and Futurist, then is it promoting native thread-based Oslo services? Because as far as I understand, both that library with the name of starting with C and the Futurist is based on native threads. Am I understanding it correctly?
Yeah, well, yeah. The goal is to wrap. We don't want to impact too many services, so we want to wrap Kotilidon and Futurist at the right place into Oslo services. We have two options: either we remove Oslo service, either we use it to lead people to the other alternative. And indeed, the model is not the same for everything. Some parts are more based on thread, group of thread, etc., etc. So I don't know if you see the spec proposal. Maybe you could be interested to join the discussion and see more details about that. I just put a link into the description.
Yep, thank you. I saw that. I reviewed it. I think. So my question is still that does Oslo service with Cotyledon and Futurist promotes native threading for the clients of Oslo service? Like the source,
Yes, we do.
Okay, thank you.
So just one comment on that. Because it's starting with native threading as a base, it doesn't preclude you using async.io within that native thread that you're using as your main thread. So if you want to mix in async.io into that, you can. One obvious thing to keep in mind as well is that Oslo messaging has had two executors for a very long time. One is Eventlet based, the other one is based on a Futurist thread pool. So you do need to make sure that you're setting that appropriately. In Nova, I was proposing actually hardcoding it based on what a monkey patched. What I noticed on the Neutron changes is there's actually a way to detect that already built into Oslo messaging. So if we actually stopped hardcoding it, it would actually do the right thing. Nova for years, and probably other projects for years, have hardcoded Eventlet there, probably because that auto-detect mechanism wasn't there. So there might be some tech that we could remove there just to have it automatically use the right one. One of the discussions in that spec is for the Oslo backend is how we import either a specific module, or do we set a variable or config option to choose. So we might want to unify on a general approach to that for all of the Oslo libraries, but just calling out Oslo messaging because it has the ability to figure out which one it should use. So in that particular case, we probably can just let it.
Yeah, referring back to your statement that you can run the event loop in each thread you get from Oslo services, that's true. And that ties to my other comment in the doc mentioning SGRef, where I just read the README on the landing page of GitHub, and there is a section of hard edges, or I don't know what was the exact wording on transitioning between sync and async functions with the SGRef library. So I don't fully understand those statements, but it's very scary based on the fact that they are listing technically complicated issues when you are transitioning between those boundaries, between sync and async boundaries. So I wouldn't try to do that as a first step if I can avoid it somehow, the transition between those.
Okay, any question? Concerning that point, in my opinion, this is more a thing that we have to decide together to choose the right server, the right application layer, etc., etc. Both proposed there are, in my opinion, well-managed, but yes, you are true. Maybe SGRef is not the right client for us, etc., etc. We have also the same kind of decision to have with the HTTP client library, because we already seen some name appear like IOHTTP. I proposed a fast API also, which could be a credible alternative. I'm not aware about HTTPX. Go ahead, Sin.
So one comment on Fast API, I believe that's fairly tightly coupled into there's an equivalent to Oslo Virgin Objects that builds on data classes. It's like begins with P. I can't remember, but it has its own data structure formatting stuff they use for serialization. So I'm not entirely sure how easy of a drop-in that is. But that's just something to consider, that some of those frameworks assume that you have an object model that it is owning to do the validation of requests, etc. So we just need to be careful that we can retrofit it without pulling in a lot of other dependencies if we're looking for alternatives.
Exactly. Do someone have some suggestion, comment?
I think there was a question on the chat about ASCII, and there was another discussion parallelly about running DevStack under uWSGI. And is there a plan to switch to ASCII at some point?
Cyril, do you want to give us some?
Yeah, it's just there's currently a discussion led by Steven on deprecating Eventlet on DevStack and also mod WSGI and running everything under micro WSGI. And I mean, if we're going to switch to ASGI, is that going to be an issue? Do we have to drop micro WSGI as well, or I'm a bit confused?
So one of the things that Stephen's trying to do is minimize the different ways we have in DevStack of running things, especially when they're not using different jobs. I don't think he would care if we were to remove uWSGI and put in an ASCII server in its place, provided we don't have to support 4 different variants, right? So that's what's motivating his current work, is to simplify what we are testing in DevStack into something that's kind of common. So uWSGI is what most things we're using. That's why he's trying to simplify that to just be uWSGI at the moment.
I mean, right, but on the other way, and that's what he's also trying to do. We want to be as abstract as possible with the framework, right? I mean, the fact is that we are making a few assumptions in the code, and we would like to remove those specific assumptions. And my concern is that if we go with some specific assumptions about the framework model, well, I mean,
you're mixing 2 things. One is the application server, and the other is the application framework. So what he was looking at is making sure that we use uWSGI as the application server. It's not infecting how we write the WSGI application itself. That could use Flask or any other framework there. So he's just looking at purely as the execution context that takes that application and runs it. So they're 2 separate conversations.
I mean, are you saying that if we go with ASCII, we can run any WSGI server we want?
You can run on any ASCII server, and some of those support WSGI applications, partly kind of as a transition plan. If you go with
just...
Sorry, go ahead.
You can run a WSGI underneath an ASCII server?
I believe so. I need to double check that, because that comment was made yesterday that there is support in some of the ASCII servers to run existing WSGI apps within them. I don't think that gives you any parallelism. Advantage, it's not magically faster, but it can just run. So if you're trying to use a single server, it kind of like, Nginx can be a reverse proxy, a web server, and a whole bunch of other stuff. Some of the ASCII servers support running WSGI just because.
Okay, we need to be really clear if we're talking about server applications running or the interface that you've programmed your application in, because you have a WSGI app, it's the start app, callable, and then under ASCII, if I'm not totally mistaken, it's a different. You have to use an async def at the Python level, is what I vaguely. Yeah. Anyway, I think we need to always be able to run threaded style WSGI, and we'll need to support async style ASCII Python code. As far as the server that runs them, that's kind of a different concern, and you definitely do want to have threaded concurrency if your program is using threaded WSGI. That's what I would put out for that. And if you're running an ASGI, you want to have an async server as well, so you can have concurrency under async.io. You wouldn't want to run.
Yeah, so you could do something like use a waitlet to just wrap your ASCII implementation and give it as a proxy, but like eventually we want to actually go to something that's native, right?
Yeah, I'm not pushing for 8 waitlet to be anywhere. So it's out there, but let's not reach for that first, unless you really want to. But I wouldn't start with that.
So
I would start with having both worlds in play. WSGI, ASGI are both going to be there because different servers are like Nova's going to threads. Glance probably has to be totally async, and Swift. It's got to be 2, is what I'm saying.
All right,
A choice.
Takashi, you want to go first?
So I'm a little bit confused about the requirement with async in the API. So I think the most of the services doesn't require it right now, right? I mean, most of the services do not really use Eventlet when the API is deployed by the WSGI. As long as the API service is deployed with the WSGI server, I mean the WSGI web server, I mean like the HTTPD or even WSGI. So I think the problem is specific to a few services like probably Nova for the async query across the cells, and Glance, which kicks out some async task for image import and probably something in Swift. But I think I would like to just make it clear that the async requirement will be specific to these 3 services, right? And not really very common among the other services.
That's what I believe that's the case. That Swift, Glance have an async, model kind of, and parts of Nova, as I understand, to query 100 cells. But that's what I've heard.
Nova has one very specific thing that uses a scattergather pattern. But that was only introduced after some performance issues that some imported very late in Nova's life cycles. Like it came in Stein Rocky-ish, so it's been around for a while. But up until that point, there was no usage of Eventlet at all in Nova's API. We have asynchronous actions, but none of that implies needing asynchronous code. So it's very minimal today. Gibby,
I think Nova's pattern could always be behind a threaded server anyway. Even if you wanted to use async.io, as you said, you can spin off an async.io, scatter gather, cool term, from threaded whatever, because you're just waiting anyway. So, but as Swift and Glance, because they're dealing with big chunks of many gigs of data, should probably have an async.io front end, which means they should just be front to back async.io in my uneducated side. That's what I think.
Okay.
Gibby, you had your hand up.
Yeah, it's just commenting back to Sean about having a framework that supports both sync and async VHGI or VHGI and ASGI. FastAP is one of the examples, so you can define your API handlers both as a sync defs or async defs, and the framework will just translate between them, probably with ASGI ref.
Yeah, no, I was just looking at the dependencies. So the one I was trying to remember was Pydantic. It looks like it's actually optional. So you can use it without needing to use that. It also uses HTTPX as one of its standard dependencies as well internally. So that's another reason I think for going the HTTPX route as a replacement for requests, because first and foremost, they wanted to keep requests API identical in HTTPX, but they then have the ability to have an async version of all of those functions as well. So it's a very easy drop-in replacement if you're already using a request in your project.
Good. Do you have other question or comment related to that? So I think the the point that we have in phase 2S is to define which library we want to use. And the goal is mostly to get consistency across the project and to avoid any kind of services management, etc. I think we can continue to the open discussion and Q&A session. So, Sean, you put discussion. I will let you introduce that.
Yeah, so this is a very specific niche edge case we have in, well, it may not be that niche, edge case we have in Nova that we don't have a good pattern for, from my perspective, without having to use async IO. So specifically, we use Eventlet timeouts as a context manager to in the scattergather thing, so that if one of the cell databases happens to be down, we don't just wait forever. We've discussed this on IRC otherwise, and what I was basically asking is there a good known working production grade implementation of this that we could use without having to put in async IO? The Nova team is kind of concerned about mixing the different threading models as part of this transition and actually ending up at some points having 3 different concurrency models at the same time, where we have eventlet code, non-eventlet code that's using threads, and non-eventlet code that's using async IO, all trying to manage the same thing. Even if it's not in the same process, that is scary to us. And that past experience with people debugging async IO is it's harder than doing it with eventless. So we want to keep this as simple as possible. I think the direction we're going to go in for now is twofold. One, we're running in a WSGI application already for this in the API case. So the WSGI application or the WSGI server has a timeout and request, and it will kill it after a while anyway and return back a 503. So worst case scenario, if we had no timeout handling at all, we would get killed after about 30 seconds when we exceed the max request length on that by Apache or UWSGI, etc. Best case, SQL Alchemy actually has the ability to create a statement level timeout. So any individual query select, updates that we do through SQL Alchemy can have the database enforce a timeout on that. So we're not using that today. We're using Eventlet to do that. But I think what we should just do is natively pass through the timeouts to the libraries that we're calling in a blocking fashion. So I think that's the direction we're going to go in. But the discussion here is basically, is there a reliable solution that we know of that works in a purely threaded context? Because we considered processes because they're killable, but having a single API request spawn 10 processes to do a scatter-gather is probably not something operators will be happy about. So we don't want to go that route because it's too heavyweight.
What's the statement level timeout in SQL Alchemy?
So in SQL Alchemy, we can pass either connection or a statement level timeout, and if it exceeds that, then the database.
Is this for async IO only? Because I'm not remembering the statement level version of this. Is that part? That's not part of the. I'm not saying it's not there. I'm just saying I don't remember where this is.
Okay, I'll need to double check because I was looking through the SQL Alchemy docs yesterday and I came across a comment saying that you can set a statement level timeout. I don't believe it's on the. Yes, I don't believe it's on the query. I believe it's actually on the connection. So I think
there's stuff on the connection for the driver. Yeah. For the MySQL driver. Sure. Yeah.
So when we're doing this scatter-gather, there's some connection pulling, but basically we're creating a new connection to each cell for this one query and then throwing that away.
Well, right.
So we could do that and set the connection level statement timeout there for this request, and that would cause those individual calls to each of the cells to timeout, and we'll get the exception and we can move on and give a partial result. Even if we didn't do that, my meta comment is there is a request timeout already enforced by the API server, which will kill that thread and everything spawned underneath it anyway. So worst case scenario, we would hit that 30-second timeout or whatever is configured by the operator, and everything will go away and the user gets a 503. This is a read-only operation as well. Like the scatter-gather is a read-only get. So it's less of a problem with transactions, etc. It's not going to end up a funky state, hopefully.
Yeah.
my take on the generic question of how do we handle timeouts is that in Eventlet we had a way to have a timeout signal in the same greenlet that requested the timeout. In threading, you cannot have that. The timer is outside of your thread, and you need a mechanism to communicate that the timeout is just triggered. And that makes the code look different if you want to translate it from Eventlet to threading, but it doesn't make it impossible to have a reliable timer. We just need to change the code, how we handle such timing. And one way what Sean described is to push down the timeouts as much as possible down to stack to the blocking calls. If that is not possible because A, that blocking call doesn't support that, or B, we have a bunch of blocking calls after each other where we have to pass the timeouts for each, but it's different timeout based on what was the previous running time, the previous blocking call. So that if it's complicated, then we can have an external timer and we can communicate the timing signal back to the thread doing the work. But then that thread needs to dynamically check for that signal all the time to be able to get notified. So that means we need to change the code how it looks today.
I just put my hand up to ask you a question, Gui. Have we got examples of where we don't have that? I guess is it when we shell out to various command line tools and they just don't have a timeout?
So
I don't have examples yet. Yeah, but
I do.
Probably show.
So yeah, the command line case is actually trivial because one, we can always just stick timeout in front of that and just have bash do it. But there's also ways to do that in Python. In that specific case, the example is Ceph. Now, Ceph, the Python bindings, if you're calling any of the Ceph CLI marshal commands, for example, those all have timeouts because their CLI does, and they're just wrapping that. If you're calling the write API to write data to a volume, there's no timeout. They do have an async API, which doesn't use async IO, but they have a generic async way of writing. And I believe that returns futures. And if it's using concurrent future, we can do result and pass timeout to that, which will give us a timeout exception, and we can decide what to do there. So right now we're using the synchronous read and write commands to do like snapshots or create the images when we're creating the stuff on the Ceph backend. So that's the main gap that I've come across so far. We have already stuck libvirt into its own native thread years ago because it has a blocking only API as well. So in that particular case, we built a queue where we put the, hey, go do this thing to libvirt, wait for the events, come back, etc. So we have experience wrapping blocking things into their own native thread and doing that even in the eventlet world before. So we'll have to kind of build that on a case-by-case basis. The specific case here is we had a pattern of we take an arbitrary function that we modify the context on to know which cell to talk to, and then we execute that inside a context manager that times out the entire block of the things we're dispatching. So that generic pattern of taking really generic opaque function that we know nothing about and having it generically time out, that is very hard. Those specific individual cases are actually pretty easy to fix one by one. Takashi also mentioned the timeout decorator. I looked at that as one of the implementations. It uses signals by default in Linux, which are only handled by the main process, which won't work under a WSGI server anyway. And we can't have the single handler propagate in. You also can't have multiple single handlers for sig alarm. So we'd have to do some like really complicated thing where we try and figure out which thread to interrupt, etc. If you use the threading input, or if you use the non-single implementation, it uses the process pool. So again, too heavy for the API. I have two different implementations that I tried already. One is using the C Python extension stable API to asynchronously raise a timeout exception into the relevant thread. That works, but the behavior is that the thread will continue to block until the underlying blocking call finishes, and then when it's resumed, the exception is raised. So if we're worried about it stealing all the threads from the pool, etc., it won't protect from that, but it will mean that when it does finally complete, it will actually go through the exception code path of timeout expired, etc.
We don't need the C extension for that. That's just a way to injecting an event to that thread, and the thread, when the blocking can returns, checks the event, and that will give the signal that it's timed out. So
we could do it via just a decorator that will generically do that, check the event, raise the exception if the event has been fired, etc. So those are the things we've explored so far. I also looked at just using asyncio for this one thing. So basically, we would spawn a thread that does asyncio run of the generic function, possibly wrapped in eventlet or waitlet, whatever. And that way we get to use asyncio's timeout for that. But then that means we have to mix and match those two models. And that might be okay in certain cases. I have a POC, I think linked here, where I'm using Annie.io, which gives us this nice decorated context manager way that's almost identical to what we have with Eventlet. But again, it's a little bit complex, and it is mixing those two models. So that might be suitable for some people. I'm not necessarily sure it's suitable for Nova.
Yeah. My reflection on that was it might work, but I don't like the complexity. So it's like what we gain is keeping the code look the same as today by paying the price of a lot of complexity instead of paying the price to changing how the code looks to be native threading and therefore a lot easier to understood because there is no hidden complexities just because you have like extra libraries doing the work or having an extra event loop doing the work. Also, I'm not sure if we do that, go that way, that we spawn a thread, we start an event loop in it, then what will happen if we have multiple parallel scatter gathers? Do we have multiple parallel threads with each having an event loop, or having a combined thread with a combined event loop with multiple scatter gathers?
What I have been toying with, but I haven't bothered to write yet, is I think we could add another futures executor, which is an asyncio executor that will spawn a single common thread that runs asyncio's event loop, and then have a way to just dispatch async task into those, right? And then we can have the same normal future base API. We pass in a function. We could assert that it has to be an async def function if you want to, or we could build us using a waitlist and just have it wrap non-async def ones into them. You have to be careful with that because if they block, in either case, if they actually block, they block the entire event loop. So if you've got multiple things sharing it, that could be a problem. But that could be a solution we could explore if other people had this use case of mainly doing threading, but wanting to do a small amount of async IO stuff piecemeal using a single shared executor. But yeah, to answer the actual specific question, my original POC was going to be spawning one asyncio loop per thread, which for Nova is fine. We run Nova in a very specific way. So our WSGI server is required to have at most one thread per process. So you scale per process. And we only end up processing one request at a time in that Python interpreter / process. So effectively, each request gets its own Python interpreter that handles that single request and dies. That's not quite correct, because what actually happens is that interpreter is re-entered and is reused up until the WSGI server decides to recycle it. So we actually may have multiple things, but the way it works today is we're only processing one request per process effectively at any one time. And that process will only have one thread at any one time for now.
When you say that we do that, is it something that we enforce in upstream to always happen this way?
If you don't, then you will get DB deadlocks. So unintentionally. It's to do with how we're initializing the global engine facades with SQL Alchemy and some other stuff. And we had some issues with Eventlet where if you have multiple threads, the exception could get raised on the incorrect thread from where it was actually happening, because you can end up, the greenlit can end up context switching between them. So we basically documented always run Nova's API with threads equals 1, and then as many processes as you like. And that's true for both running under ModWhiskey and under uWhiskey. It doesn't change that behavior. That's not entirely true. One of them handles it better than the other, but we basically say just don't try for either of them.
You saying we stay the same for threads, just for...
Can you restate that?
Sorry, you were saying we stay the same when we move to threads, if we move to threads.
If we move to threads, there shouldn't be a way for exceptions to just kind of change thread without us intentionally doing something. So we might actually gain the ability to say run Nova with 10 threads in one process. We would have to see.
Okay, that's fine. It being unknown is fine. I was just wondering if that was where the context was coming from. Got you.
Yeah.
We have to be able to do that because gather will use multiple subthreads.
Well, it's different to ModWhiskey starting multiple threads with requests.
I see.
Right?
Okay.
So
it's not threads for requests coming in. Yeah, it just
correct. All of the threads we're spawning for doing things through a thread pool are escaping the life cycle of the Whiskey server, with the exception that if you kill the process that's spawned them, it's going to rebuild the threads, right? So it's the same thing with the heartbeat in pthread config option. That was intentionally escaping it so that it would continue so long as the Whiskey server was running, but then that caused other issues. So that's why we don't recommend using that for basically anything related to Nova at this point.
You may have just convinced me to say threads equals 1, if what it's worth. But that's fine. I'm okay with that.
So what we just don't know is if the bugs we saw before would show up when we go to just using real threads there.
Sorry, I should describe what was going through my mind. So what I meant is what you were saying is that we kick off a whole load of threads, then ModWhiskey will kill the thread that's processing the request, but the other guys will just keep going. Whereas if it's in a process model, it will kill the process potentially, give or take your interpreter statement, which I think is true on the recycling front. But you would upset ModWhiskey less. Not that it actually technically matters, as you said in the read case. But.
Yeah, so if the thread pool is actually a module level global, it's going to be shared across all threads that are sharing the same process.
Oh, I see. Okay, sorry. Right.
So we wouldn't be getting parallelism on that thread pool anyway, unless we make it a thread local, which we can totally do. But that means that if one bad request is after taking everything from it, it slows down all of the other requests. And I don't like that sharing behavior because it's unintended sharing. There might be reasons to do that. It would be something we probably want to make configurable to some degree, but like keeping it simple of one thread per process for the actual API requests, and then allowing you to limit the concurrency in that thread pool or for the sky gather if it's applicable for your service, I think is reasonable.
Okay, thanks.
So I don't want to take too much more time on this. Does anyone else want to contribute to this discussion? Thoughts? I don't know.
I added a sort of segue on the Etherpad, which in my head was trying to wrap up the discussion a little bit. But I may be getting ahead of things, so tell me to shut up if that's fine. That's fine also. So what I suggested on the Etherpad was just say we transition to threads and do all these things. Like, what does it kind of look like at a very high level? So from the nuts and bolts thing, I guess, as a summary, we've said remove all references to Eventlet, clearly, because that would be bad. I think you said, I haven't put this in here. So we've got like the RPC, using the RPC can potentially move to the thread pool, right?
Yeah, so if you set also messaging to use the threading executor, it does use the thread pool. So each RPC handler gets spawned into its own thread, which basically means we can freely block on that thread as much as we like. We still have to be careful if we've got shared state and we're holding a lock, etc. But that we can basically treat that actual OS thread like it's a green thread. So any of the shared handling that we had for the shared state, we still need to keep all of the synchronization decorators, etc. But
it might be more accurate to say, but and I'm just trying to do this for clarity. In the Nova case, we were treating greenlets very much like regular OS threads.
Yes.
Which, as in the reverse, might not be so true. But yeah, because it's all. I don't want to compare it to a whiskey server, right? But we've got RPC requests coming in with background periodic tasks, and they kind of all have their own state coming straight from the database anyway, right? Approximate. It's not quite true, right? Where you said locks and other things, but
yeah. So one of the comments that could be made, which is valid, I thought it would actually be less non-deterministic when we move to threads, but it actually is just non-deterministic in a different way. So today, using Eventlet, anytime we do any kind of I/O, we potentially yield. We're not going to do that in the threading model, but the kernel can choose to preempt us at any particular point in time. So, you know, it could technically have preempted the thread that the greenlets were in before, but from the event loop's point of view, that shouldn't have changed anything when it was resumed. So we may end up with different concurrency issues, but it makes it simpler in some respects because we don't need to think, oh, I just did log debug. That means I could potentially yield here, and I need to make sure that I'm in or outside the critical section, right? To very intentional points where we yield, but we have to still be careful of that because the OS can do bad things.
So I think what will be the big difference is that we battle tested all the possible context switch places because we have those fixed in the IO places. We never battle tested any other places having a context switch, which now can happen. So we will have race conditions that wasn't possible to happen in Eventlet, but it will possible to happen with threads because it can be preempted anytime. So please be prepared for that type of things. So probably we have locks around all the concurrency issues that can happen with eventlet yielding, but we don't have locks around those concurrency issues which can only happen if you preempt it by the kernel at not a yield point today, but somewhere else, anywhere else.
Go ahead, Relaunch.
Thank you. So I have a question for you, for Nova folks in particular, but for anyone in general. So what concurrency problems or issues do you have in the Nova API? Just the API, not an agent, for example, the Nova Compute agent.
So in the Nova API, we only have one place where we use concurrency at all, and that's the scattergather. We could literally just remove that and go back to the for loop that calls each cell one by one. The only reason we don't is performance. But like that would be the super simple thing. We shouldn't have any other concurrency issues because each request is running in its own process and interpreter effectively. There's no sharing.
So my question, I'm sorry for John, I see your hand raised, but what is the concern about introducing a sync, for example, in the whiskey mod, in the whiskey server for Nova? Just asking specifically for Nova.
I don't know if you want to answer that, John, but the quick answer is we're actually considering it for the API eventually. Even Dan Smith has said that that's potentially a good place to use it. It's really the rest of the code base. And what we're concerned about is we have a lot of common code that's used both in the conductor, the scheduler, the API, and Nova, as in the exact same function is used from all those places. So we don't want to split the code base in half and have some pieces that are async only and some that are non-async.
Correct. That's the basically, if you prefer the fact that we have the whiskey application and then the RPC client in the same, if you prefer, Python interpreter doesn't really help, because then we'll need to like split that.
So I
Okay,
guess
thank you very much.
that's quite second order. I think my problem thinking about this was just I don't want to have to add a wait between in front of every save command across the whole code base. Call me lazy, but I don't know how we do that transition. I mean, it's just from a pragmatic point of view. Maybe it amounts to don't split the code base. Actually, it's the same difference, perhaps.
Well, that's one of the places where Eventlet could help, because Eventlet could actually put the awaits and stuff internally and then make it look like it's still blocking from the other point of view. But
well,
you mean a waitlet? You mean a waitlet?
Yeah, but I don't like the idea of having to just go everywhere that we're doing an RPC call and modifying that, right? Even if it's just adding a wait, that's a lot of code churn for very little benefit.
Okay, let me be. Sorry, please go. Please, Mike,
I mean,
go on.
no. I was just about to say that we'll have this kind of Eventlet Nova specific execution at the PTG as well during the Nova sessions, probably on Friday. So maybe it should differ like the Nova specifics during that specific Nova session. And if people want to join, then I would be sure that that I will send the right agenda.
I will, because actually I would like to think with you what are you going to do, because sorry, to be honest, I see this effort for Neutron useless because we don't use this architecture at all. But if we are going to combine, or not to combine, if we are going to unify the API service to something compatible with async, I don't know how much effort that will take. But anyway, thank you very much for the heads up of the Friday meeting.
There's one final bit I had on the Etherpad which we could skip, but it was more from an operator point of view. Say we have this magical code base that now does both things. How do I move from Eventlet to threading? What does that actually look like? The immediate concern at the top of my head was more just, given I've got a cloud that's now tuned for a certain number of workers and processes and everything else, how do I get from the Eventlet world to the threading world without just timesing everything by 3 or something arbitrary, which might not be bad, but...
Yeah, so my original hope, at least for Nova, was you wouldn't need any config changes, and it would effectively work the same. And that's not going to necessarily happen, but that was my hope.
Yeah,
I guess what I mean is I'm going to have to bump the numbers, right? Because the concurrency would be less.
Hopefully not, because a lot of Nova is not highly concurrent anyway. We're often IO bound, waiting on other things, so we may need to, and that's one of the things that we're going to have to measure, I think, as we go. So I don't know if we want to like pull in metrics from Mali or is it Browbeat? Like there's other things like that, but we will need to have guidance for operators on this is a change.
At least for me, the main concern that I have with the world change is about the performance. And I mean, if we go on some route for every single project, then my main concern is again about like the performance change. I totally understand John's point about you should be afraid of changing, of tuning, you should be afraid of tuning some stuff, I will say. So yeah, I honestly I'm wrapping my head from like a couple of weeks, and I don't have any specific way to say, look, that's gonna be fine.
So I'm not expecting it to be perfect in all cases. I just kind of want there to be a recipe, and I'm okay if the recipe is take one Nova API service, switch it, panic, bump the value a bit, then feel happy again, rinse and repeat. Like I'm totally fine with that. That seems like a totally fine way to go. I just know that what that statement says is there's an implication that there's a version of I'm using Nova, right? This applies to anything. There's a version that supports both threads and eventlet, so I can do that transition. That's quite a wild statement, right?
Yeah, so
I mean, maybe I do it across upgrade slowly, but that's even a worse statement, right?
We were looking at moving each deliverable to either be threaded or not. So we could see. Go ahead, Takashi.
Sorry, Takashi.
Yeah, so yeah, we discussed a similar thing when we were, I was discussing the initial also spec with Daniel. But at this moment, I think, so there are two options we may have. Is the first one is to keep the config option there to let operators to select the mechanism and maintain maintain the logic for two concurrency mechanism, Eventlet and something else. And the other will be to, not exposing such kind of options and forcibly migrate to the new, the threading mechanism when the team believes that it's already ready to replace the Eventlet. So I kind of agree with the concern there, but at the same time, if we want to let the operators to select the threading model, which that means that we have to maintain tons of code to support we have to complicate our code to support two models.
I actually hope that CI will show some performance.
Yeah, but
I mean, for me, CI is the canary. Upstream CI is the canary. As soon as we switch to, for example, to native threads in case of Nova, and we say we don't need to change anything, then I'm pretty sure that then all the jobs will probably.
So we have a POC of that, and it's already passing to certain degrees, right? So
Right.
Found an issue with my timeout handling and how I'm timing out the stuff in this gata. That's only in the failure case. So in the green happy pack case, it's fine, which is why Tempest passes, right? Because we're not actually getting disconnects. So we can get some feedback there. The question, I guess, that we'll have to bring to the Nova topic is, will we actually write the code so that you can actually swap? It's much easier to go between eventless and threads, by the way, than eventless and async IO, because then the function signatures don't change, just how we're running them. So we can discuss that. I took the simple approach of try to move individual things one at a time and not give the option. So if we're happy that the API can now run without eventless, we just don't monkey batch. We can totally make it configurable, but that's just not what the POC was focusing on.
So my point about CI was about the fact that I wasn't thinking about a single change modification, but like rather once we are done with changing all the world, then at scale, when every single change is basically running against the new threading model, then if Nova starts to bubble up,
I don't think that's practical. We need to be able to deliver this over a number of upstream releases. And that's why I wanted to do one entry point basically at a time. So none of our CLIs actually need the eventless. So that was part of the initial work, was group those into a thing. They just won't be monkey patched. They won't use eventless anymore. The Nova API was going to be the next one because it's the one that uses the least amount of eventless out of everything else we have. And then the hardest one is probably going to be the compute agent. The conductors and the schedulers can be ported kind of one at a time. And if we manage to get one of those done a cycle, that might be good. But I kind of feel like it'll be API, then conductor and scheduler, and then finally compute. Maybe it'll go a different way. I don't know. But that was kind of what was in the back of my mind.
Yeah, I totally agree with you.